So you want to learn game hacking? Well, luckily for you, you've come to the right place. Welcome back to another SE Programs video, where today I'm going to be kickstarting my new series on introducing you guys to the art of video game hacking. Now with that out of the way, let's get started. As you probably can imagine, you're going to need some tools to do this. However, for now, all you're going to want to install is Cheat Engine and Visual Studio. So to install Cheat Engine, guys, you want to go to cheatengine.org. This is the only place you should be downloading Cheat Engine, and you just want to press download Cheat Engine. Now from memory, the installer does have ads, so just make sure not to install the ads, just install Cheat Engine. No, this isn't a virus. Your antivirus may flag it though, because it does. Well, because it does open programs, read memory, disassembles them, does all sorts of things that a virus would do, but it's not a virus. Okay guys, now after you install Cheat Engine, you want to install Assault Cube. Assault Cube is basically this really old FPS game that pretty much everyone learns game hacking on. It's really good. It's not too complex. It doesn't have any anti-cheat or any anti-debugging on it, so it's kind of perfect to learn on. So you want to download this. Alrighty guys, so once you have the two installed, you're going to want to open them both. Now, as you can see, I'm in Assault Cube. It's a pretty basic FPS game. So to get started, you want to come up to this top left of Cheat Engine and press this. You're going to want to select Assault Cube and press open. This is basically going to attach Cheat Engine to Assault Cube. Now to get started, I'm going to show you changing the ammo counter. As you can see right now, we have 20. So what we want to do is we want to select 4 bytes. And we want to have the exact value. We're going to press 20 first scan. As you can see, we found 2,223 addresses in Assault Cube that hold 20 right now. Now, most of these are going to be unrelated. In fact, 99.9% of them are going to be unrelated to our ammo count. So what we need to do is we need to keep searching. And the way we do this is we shoot a couple bullets. As you can see, it's down to 18. We're going to change this value to 18 now and press next scan. And as you can see, we went from 20 to 2. Now, how do we test which one's the real address? Well, for starters, when we shoot, we can see they both go down. However, what we can do is we can freeze it. Now, if we freeze this one and shoot, as you can see, our ammo is frozen. In fact, we practically have unlimited ammo, whereas this one kept going down. So we can delete this one because we know it's not the real ammo address. And if we really want to, we can change this to something like 200. And now we have 200 bullets, as you see. As you can see, now with this ammo, this is pretty much your first hack, or your first time ever hacking a video game. And it was pretty easy, wasn't it? All we did was change the address. Now you might be thinking, what happens if I close Assault Cube and reopen it? Well, memory constantly changes when a program is rerun. In fact, this address will probably not have anything to do with ammo when you reopen it. The address constantly changes. That's because this is a dynamic address. Now, in order to fix this, we need to find static addresses. Now, you can pointer scan, but more often than not, you will inevitably find yourself reversing to get a static address. So that's what we're going to do. So to do this, we're going to make a new scan. I'm going to scan 100 for our health. Now, the reason we're doing this is because we're going to try and find the local player from the health. Now, on screen, I should have a diagram of how it works. But basically, the health will be a certain number of bytes in front of the player value. And if we find the player value, we can also find the ammo value. Now, because I have done this before, I have learned that finding the player value from health is a lot easier than finding it from the ammo value. So to get started, we're going to throw a grenade at ourselves. And that did nothing, I was too far. 47, so we want to change this to 47. Next scan. Cool. Now one of these is going to be the health value and one of them is not, so we can just set this one to 100 and test. Okay, and we'll just freeze it. Just double make sure, you know. So we know this one's the real health value. Now in order to organize your cheat table, what you can do is you can add description. So we'll do clip and we'll change this to health. Now what you're going to want to do is you're going to want to find another grenade. Okay, now the reason you have to find another grenade is because what we're going to do is we're going to right click and press what writes this address. Yes, so now attach a debugger. And you simply just want to throw this nade. Alrighty guys, so you should be able to see these options. Now, if we look here, this looks really similar to the diagram I showed before. You can see a player value plus EC. Now, this could be the health value. Now, we don't know because, in fact, any of these look the same, right? So you got to try and test it. But ECX is a value and so is the addresses. If we look here, we can see them. Now, I have tested these, so I know ECX is the one. But in reality, you're going to have to try and test these. So if we grab ECX and assume it is the local player, which it is, we can copy this. We can add the address here. To do that, all you do is add address, paste it, like so, and it'll add. As you can see, I've already done it. Now, what you want to do is you want to press disassemble this memory region, go to tools, dissect data / structure, and it'll bring up this window. Now, for you, it won't have anything here. All you're going to do is press this, define new structure, and OK. And then once you do that, it'll look like this. Now, you're probably looking at this and thinking, well, what the fuck is this, right? This is really confusing. But if we go back here and remember EC, we know that we see 100. Now, if you don't see 100, all you want to do is right click, change type, and select 4 bytes, so you see 100. But this must be the health offset from the player. So if we change this to like 43, as you can see, our health right now is 100. And we press OK, we go back to the game, you can see we have 43. Now that's really cool. But what else can we find here? Well, let's try finding the player's ammo. So as you can see, we know the player's ammo is 20. So we got to try and find 20 somewhere in here. Now you're probably thinking, well, none of these look like 20, right? And it can be hard, especially when it all looks like this. But what we can do is we can shoot and we can notice changes, right? So whenever we shoot, we can see that 2C is changing. Is this it? No, as you can see, this is not it. Now what we can do is we can keep scrolling down. In fact, let's have a look here. Well, that's really interesting. If we look at 140, we see it changes when we shoot. Now, but chances are it probably isn't a pointer. In fact, if we change it to 4 byte, we found the offset for our ammo. In fact, we can change this to 200. And as you can see, we're back to 200 bullets. That's pretty cool. So what you're going to want to do is you're going to want to note down these addresses. Alright, so what you want to do is you want to open any text document that you have. And because we know the offset for ammo and health, what you want to do is player clip equals player plus 140. 0x 140. That's the offset for our ammo. And we know health is EC. Player health is player 0 EC. There we go. Those are the two addresses that we have. Pretty cool. Now we can minimize this, but what we need to find is the player address, because while these offsets from the player are static, the player address we have right now is dynamic. So you might be thinking, well, how do we find that? What we want to do is we want to copy the address. We're going to go hex, new scan, and we're going to paste what points towards our player value. And as you can see, we got 82 results. That means 82 addresses are serving as pointers towards our address. Now you might be thinking, well, what's a pointer? A pointer is basically an address that points to another address in layman's terms, right? Now, when looking at all these, you're thinking, how do we test these? How do we find the right one? Well, in Cheat Engine, any address that is green like this means it's a static address, right? So we're going to copy all these and paste them down here. Now, when we disassemble these addresses, we can see really interesting stuff. If we go tools, dissect, oh, that didn't copy it. We'll just paste it in here like so. We can see that that's our player address, right? We know that this address works, it's fine. So this is our local player address. So if we go back to here and we write local player, we know local player equals the base address of the game. Now base addresses are static. In fact, base addresses will never change. But this is the base, this is that. But this is the address for the local player. Base address plus this, 0x, because why not? So now that we know this, let's get started making a basic cheat in C++. Okay, so to get started, you're going to want to open Visual Studio. You're going to press create new project, and we're just going to do a console app. Press next, and you can name this whatever. I'm going to do first cheat YouTube, like so, and press create. Pretty cool. Now you can delete all these comments because we don't actually need them. What we're going to want to do is we're going to come to this header files. We're going to right click, add a new item. I'm going to go to header file. I'm going to do memory.h. This is going to be our header file. Now before we get started, you're going to want to define these few things. Now don't worry about the error here. We're going to add the end diff later. But for now, we're just going to want to put this. We're then going to want to make a new class called memory. Now basically this is our memory class, and these are all the functions. We have read memory, write memory, get module base address. Now I'm going pretty fast over this because I don't want to spend too much time going in depth into how the memory functions work, but pretty much all we're going to be using is the Windows API to read and write memory. Because Windows has inbuilt functions to do this, we're just creating a wrapper for it. After we do that, we want to write these lines. Basically, what this is going to do is it's going to open a handle to the process. Think of a handle like a tunnel or a connection. Basically, we're connecting our program to the game we're trying to hack. Now, this is all you want to do. I wouldn't stress too much about it. You can write any error message you want here. In fact, you don't even have to have an error message. It's whatever. I just have it there for debugging purposes, but it's completely up to you. And this just basically means that if the process isn't running or whatever, we just close the handle, right? It's good practice to have this. Okay, next we're going to write our read memory function. Now, this is pretty simple. As you can see here, we're actually calling the Windows API to read memory. We're just making a nice wrapper of it, as you can see. We're using a template just because, you know. Next, we want to write our write memory function, which, as you can see, just uses the Windows write memory function. We've made a nice wrapper for it using a template. Cool. So after we have our read and write memory function, we want to do our get module base address function. Okay, so basically what this function does is it gets the base address. So all we're doing is we're passing through the process and handle of it, and then we're iterating through all the modules in that process, right? So by doing that, to do that, we're just creating a snapshot of all of it, then we're iterating through all of it, and if we find the base address, then we just return it as a uint pointer underscore t, as you can see here. Now, that's pretty much it for our memory.h function. Oh, you just want to put check at diff. Pretty cool. So that's how memory function's done. We want to come back to our CPP file, right? Now, for those of you who've never worked in C++, basically the int main function is where everything happens. You know, in languages like Python, we work top to bottom from the whole file, whereas in C++, we work top to bottom from like within this function, right? So pretty cool. We're gonna change this to super cool salt cube cheat because we're basically Sigma hackers. Pretty cool. Now what we want to do. Okay guys, so before we begin actually using our memory function, we want to write a quick function to get the process ID of a salt cube. And you also want to include memory.h up here. Now we're using these because it's a file and a library, yada yada yada, whatever. Now you want to include memory.h as well guys, just up here like so. Now get process ID. Basically what this is doing is it's creating a snapshot of all the processes on our PC. It's also taking this wide string input of the process name, and then it's initializing this structure, which basically this just holds information of processes, the structure, so it also holds a process ID. And then what we're doing is we're iterating through all of them, and then we're seeing if the process name equals the exe file name. If it does, we get the process ID and we return it, and we also close the handle. So now that we have that out of the way, we want to begin our cheat. Okay, so the first two lines you're going to want to write are these ones. We're going to define our target process, which in this case is a salt cube. Now we're not writing a salt cube. As you can see here, we got to write ac underscore client.exe because as we're looking for the exe name, this is it. Pretty cool. And we're adding an L here because it's a wide string. Then we're calling this function get process ID of target process. In fact, if you didn't want to, you could probably just close that out. Get that. Done. We condense it down to one line live, guys. That's pretty cool. Okay, then what we want to do is we want to do if brackets process ID 0. This means basically it didn't find our process. What we want to do is we want to do std cout error process not found. We could just sleep for like 3 seconds and then we'll just exit the program exit. We'll do code 1337 because we're super cool hackers. Okay, then if we do find the process ID, we want to do memory process ID. Like so, we're just initializing the memory class for this. Then what we want to do is we want to initialize some addresses or get some addresses, sorry. So we're going to uint pointer underscore t equals memory. Sorry, this should be ptr. So t base address equals memory dot get module base address, and we just want to pass through this like so. After we do that, what we can do is we can test our read and write memory function. So we can do, well, have to be an integer, because int player health equals memory dot read mem, and then int, so we're reading an integer, and the address is, oh, actually what we should do is we should define local player uint ptr underscore t player memory dot read memory ptr underscore t base address plus, and then what did we say our player was? Our local player was this. Cool. So that's getting local player. Then we want to do local player plus what's our health offset? EC to do int player clip for our clip. We got memory int local player plus 0x140, was it? Yeah, 140. Memory. Cool. And then we can just do std cout player. Just put clip. Just want to do player clip and std though, because we're ending a line. Pretty cool. So now we're just going to output this, and then what can we do? We can do, I'll show you guys how to add hotkeys, why not? Those include windows.h, let's do while brackets true, sorry, lowercase, we're not in Python anymore. If brackets get async key state bk underscore, yeah, we'll do escape. If they press escape, then what we want to do is we want to do memory dot write them. We'll get our health. We'll write 200, so we're gonna give ourselves 200 health, and then we'll go here 140. Let's give ourselves 0x140. Let's give ourselves 300 bullets. Pretty cool. So that's actually our first cheat done, right? So actually what you should technically for optimization, you should just add sleep of like 5 milliseconds so you don't destroy your PC. But yeah, if we run this, pray for no errors, as you can see it read our health and ammo, and if we press escape, there we go, sorry, pressed F and escape. But yeah, as you can see, we have 200 health and 300 bullets. So you guys, that's how you make your very first cheat in C++. As you can see, we have health and stuff. If I press escape again, it sets it to that. Now, you could imagine if you wanted to make infinite ammo, you just remove the if get key, and you just constantly write it. But yeah guys, next video we're going to be going over assault cube some more. We're going to be reversing the entity list, so you can find other players' positions and health. We're going to make a basic TP, like to kill all the enemies. Yeah, and then yeah, hopefully after that video we'll be making an ESP. So yeah, if you did enjoy, be sure to like and subscribe, join the Discord for support, and follow me on Twitter. See ya.